Today, we are diving deep into the highest stakes world of elite Linux troubleshooting. This isn't about your run-of-the-mill fixes. We're talking about those critical, system-down, all-hands-on-deck failures that can make or break a company. So our goal here is to give you the mental framework the pros use to solve the absolute toughest problems, especially when the pressure is on. So let's set the scene. The pager goes off, alarms are screaming all over the place. A critical service is completely down. The pressure is mounting. What is the very first thing you do? Seriously, your gut reaction right here is what separates a senior engineer from a junior one. And here it is. This is the golden rule. It's the core philosophy. Before you even think about typing a command to fix something, you have to get into this mindset. See, it's not about having some magic command memorized. It's about having a methodical process. Honestly, this is the single most important signal of seniority you can possibly show. Okay, so here's the game plan. We're going to start by really digging into that golden rule. Then we'll run through two intense drills. First, we'll untangle some serious disk and I/O chaos. And after that, we'll solve some common CPU and memory mysteries. And finally, we'll pull it all together into a universal template you can use for pretty much any problem that comes your way. All right, let's jump right into our first drill, disk and I/O chaos. You can think of this as case file number 1. These are the kinds of problems you can't just fix by throwing more CPU or memory at them. Nope, they require a much deeper understanding of how the system actually works. And here's our first symptom. Oh, it's a classic. I guarantee every single engineer has seen this one. Your logs are just screaming, no space left on device. Services are failing to start, writes are failing, the whole system is just grinding to a halt. Now, your first move is not to start deleting random log files. No way. Step 1, confirm reality. df-h tells you the state of the file systems. Is it the root file system that's full, or maybe it's /var, or some other dedicated data volume? Once you know which file system is full, then you can grab a tool like do to start hunting down where all that space is actually being used. What's really interesting here is how this plays out in a high-pressure situation, like a job interview. Just saying this one sentence aloud, I always check file system usage before touching files, signals immense senior judgment. It shows you're methodical, you're careful, you're not reckless. It's a huge green flag. But then you hit the classic trap. You run do, you add up the sizes of all the files, and the numbers just don't match what DF is telling you. There's like gigabytes of space just missing. And that's because do can only see the files that are visible in the directory tree. But the kernel, it knows the real story. A process has a file open that you've already deleted, and it's basically holding that space hostage. So how do you find these ghost files? Well, this is the magic command you're looking for. lsuf, which stands for list open files, piped to grep for the word deleted. This will immediately show you every single process that's holding onto a file that doesn't technically exist on the disk anymore. And this all comes down to a fundamental principle of any Unix-like system. Disk space isn't reclaimed the second you run RM. It's only freed when the very last process that was holding that file open finally closes its connection, its file descriptor. Really understanding that is absolutely key. Okay, let's move on to our next I/O mystery. And this one is even more unnerving. You've got a process that's completely frozen. It's not responding to anything. You try to kill it, nothing. So you pull out the ultimate weapon, kill 9, and still nothing. The process is literally unkillable. So your first step is to check the process state with a tool like PS. And you're looking for one specific kind of ominous letter, D. That D stands for uninterruptible sleep. It means the process is stuck deep inside a kernel call, probably waiting for I/O, and it cannot be interrupted by any signal, not even the all-powerful sig kill. Your very next stop should be dmej to see what the kernel itself is complaining about. The moment you see that D state, your entire mental model has to shift. This is what we call senior framing. You immediately stop debugging the application's code. You have to realize you're no longer dealing with a simple software bug. You're now investigating a problem with a kernel, or a driver, or the underlying storage, or maybe even network hardware. It's a whole different ballgame. All right, let's switch gears and move on to our next drill, CPU and memory mysteries. We'll call this case file number 2. These are the kinds of problems that often seem totally counterintuitive, where the symptoms can point you in completely the wrong direction unless you know exactly what to look for. Okay, here's a perfect example that trips up so many people. Your monitoring dashboard shows the load average is through the roof. We're talking 50, 100, maybe even higher. But then you look at your CPU utilization and it's just sitting there at like 5%. The machine is basically idle. How is that even possible? Well, the answer lies in understanding what load average actually is. It is not a measurement of CPU usage. Let me say that again. It is not CPU usage. It's a count of the number of processes that are either actively running on the CPU or are in that uninterruptible state, waiting for something, like a slow disk or a network connection. And that right there leads to the big aha moment. This is the key realization. The reason the CPU is idle is because dozens, maybe even hundreds of processes aren't even trying to use it. They're all just stuck in a long line, waiting for a slow disk or a hung network mount to respond. The high load isn't a CPU problem at all. It's an I/O problem in disguise. Okay, on to the next mystery. A critical service just vanishes. There's no error in its logs, no stack trace, no crash dump. Poof, it's just gone. And then a moment later, your process manager restarts it. It looks completely random, and it's probably driving you absolutely crazy. Well, the cause is almost never actually random. The very first place you should look is the kernel log. This one simple command, dmaz-grep -i-oom, is your smoking gun. If you see a line in there that says something like, out of memory, kill process, you have found your culprit. It was the OOM killer. And here's another one of those critical lines that just screams senior level understanding. The OOM killer isn't some random villain. It's a survival mechanism. When the system is completely, totally out of memory, it has to make a tough choice. Either the entire kernel panics and the server crashes, or it sacrifices one process to save all the others. It uses a pretty smart system to pick the best candidate to kill. It's not random at all. So we've gone through some really specific drills, but now let's zoom out. Let's look at the universal template, because this is your key to solving any problem. You see, underneath all of these different scenarios, there's a single powerful pattern. And here it is, 7 steps. First, confirm the symptom is actually real. Then, scope its impact. How bad is it? Third, gather signals using all the tools we've talked about. 4, form a few educated guesses, your hypotheses. 5, methodically test them one by one. Once you find the cause, step 6 is to mitigate the immediate problem to get the service back up. And finally, maybe the most important step, figure out how to prevent it from ever happening again. You see, this template is about more than just solving the technical problem. It's about how you signal your value as an engineer. Senior engineers, they ask clarifying questions. They follow that hypothesis-driven flow we talked about. They explain what they're doing calmly, even under intense pressure. They are obsessed with prevention, not just quick fixes. And crucially, they have the confidence and maturity to say, you know what, I don't know the answer yet, but here's my plan to find it. Ultimately, elite troubleshooting isn't about memorizing a bunch of commands. It's about having a repeatable, logical framework that you can apply to any unknown, stressful situation. You now have that template. So the only question left is, what problem are you going to go solve with it first?